All right, guys. So what we're talking and starting about, or not talking about starting, what we're starting today is Chapter 9. Chapter 9 is going to be revolving around triangles, mainly right triangles. We will talk about using sine, cosine, sine and cosine, not tangent, in triangles that do not have a right angle. Yep. Now, we won't talk about sine, cosine, and tangent today. We're mainly going to be focused on right triangles and finding missing sides and using a formula to be able to find more information about the triangles. So, the first thing we're actually going to talk about is the Pythagorean Theorem. In a right triangle, the square of the leg of the hypotenuse is equal to the sum of the square of the legs of the length of the legs. So, or as most of y'all know it, a squared plus is equal to c squared, or Pythagorean theorem. And the hypotenuse is always going to be the longest side. It's going to be the side opposite the 90-degree angle. So C is always opposite the 90 degrees and will be the biggest side, the longest side length. Now, if we have three positive integers for A, B, and C that satisfy the Pythagorean theorem, we call them a Pythagorean triple. So any integer, so any number that is not a decimal or a fraction that makes the equation a squared plus b squared equals c squared true is considered to be a Pythagorean triple. Now, these here, 3, 4, 5, 5, 12, 13, 8, 15, 17, and 7, 24, 25 are 4 different Pythagorean triples. The ACT really liked using 3, 4, 5. They like using this in a lot of their problems for finding lengths. Yep. Yep, I'll take those. Guys. And they will sometimes use these others on the ACT. Now, 3, 4, 5, and these here are unique Pythagorean triples, but we do have other forms because we can also have multiples of them. So 6, 8, 10 would be another Pythagorean triple. We just took 3, 4, 5 and multiplied it by 2. Or 9, 12, 15. We just took 3, 4, 5 and multiplied it all by 3. So really any iteration of 3, 4, 5 would also work. Well, we can actually do the same with the rest of them. And you don't have to write all these down because this is just taking those and multiplying by a certain amount. So the first thing we're going to be doing is actually using the Pythagorean theorem to solve for the missing side length. So find the value of x and then tell whether the side lengths form a Pythagorean triple. So when we look at this here, which one of these 3 lengths is going to be the hypotenuse? X, because it's opposite the... So for our theorem, a squared plus b squared is equal to c squared. The values of a and b are 5 and 12. So 5 squared plus 12 squared is equal to x squared. Now at this point here, we can simplify and solve. So I can do 5 squared. 5 times 5 would give us 45. 12 squared, 144, is equal to x squared. 25 plus 144 is 169. And last but not least, we would square root. Is the square root of x squared is x. Because whenever we take the square root of something, we're finding what number times itself, or what times itself would be that term. And for x squared, well, it would be x. Because x times x would give us x squared. So the square root of x squared is x. Now we need to find out what number times itself is 169. 13. Now, for the most part, we're just going to consider the positive case, because negative 13 would actually also work. Because negative 13 times negative 13, well, the negative and negative would make a, and 13 times 13 would be 169 still. But since we're talking about a length, lengths can only be positive. So our missing length over here is 13. So is this a Pythagorean triple? Because we have 3 integers. We have 3 numbers that are not fractions or decimals or irrational numbers. Any questions on this here? Be ready for the next one. So, again, we're wanting to find x and then determine if it's a Pythagorean triple. So, which one of these is going to be the hypotenuse? So the x is going to be the hypotenuse. So in our a squared plus b squared equals c squared, our c value is x. So we'd have x squared. Now the values of a and b are 5 and 4. So we can say 5 squared plus 4 squared. Now looking at this side here, 5 squared plus 4 squared, is there a variable anywhere on that side? Is 5 squared or 4 squared a variable? Well, no, both of those are numbers, yes? Can I type 5 squared plus 4 squared in the calculator? Yeah, I mean, if we wanted to, we could type that entire side, this entire side over here into the calculator. X is on the other side. So here we can type in 5 squared plus 4 squared and get the answer. Because if we did it step by step, it would be 15 plus 16 is equal to x squared. And it just tells us that x squared is equal to 41. So typing 5 squared plus 4 squared into the calculator would give us the answer. Not the exact value of x, but it would tell us what 5 squared plus 4 squared is. Because we still have to do one thing first, which is square root both sides. And the square root of x squared is x is equal to, but we don't include the plus or minus because we're only looking at the positive case. And if we type the square root of 41 in, we get I think it tells you the square root of 41, which is approximately, as a decimal, it is 6.3, I think. Because if you take the square root of 41 and hit the approximate button above it, so above enter, the button right above enter. We'll take the approximate. If you hit it again, it'll take it back to a square root. So the hypotenuse here is the square root of 41. So are these Pythagorean triples? No. Because we need 3 integer values. Integers are positive or negative whole numbers. We don't have decimals or fractions. So this here would not be a Pythagorean triple. Questions on this here? Okay, so we're using the Pythagorean theorem. And again, the reason that we know we can is because it does have a right angle. The Pythagorean theorem only works on right triangles. So if we're looking at this one here, which length is the hypotenuse? Because the side opposite the right angle would be the hypotenuse. So our value for C here is 10, and it would be squared. And the values of A and B would be? So 7 squared. Now we need to solve for the value of X. Now, here, do we have all numbers on the same side? No. So unlike the last one, we can't just type everything in. Like we can't type X squared plus 7 squared into the calculator and get the correct number, because we don't know what the value of X is. Now I can find out what 7 squared is. 49 plus X squared is equal to, well, we can figure out what 14 squared is. Now what do we need to do next? We need to subtract 49 from 196 to get X squared by itself. And if we subtract 49 from both sides, these will cancel, leaving us with just X squared is equal to 147. And last but not least, what do? We would square root both sides, which would tell me that X is equal to and that would be the answer. And if we approximated it, what would it give us? 12.1. Give me 3 more decimal places after that. And it continues on. It's a non-repeating, non-terminating decimal. It's an irrational number. Now, that tells us that the missing side here is 7 square root of 3, or approximately 12.1243, continuing on. So are these 3 Pythagorean triples? No. But what's also interesting is that, well, I'll write it up here, 12.1243. Is this side length bigger than 14? No, because again, the hypotenuse is always going to be the biggest length. So if we're solving for the missing sides of a triangle, and the one we're solving for is not the side opposite 90 degrees, we know whatever that length is can't be bigger than the hypotenuse. So if we do get an answer where the value is bigger than the hypotenuse, we know something didn't work out right.
How do you read, like, upper X? How do you, like, read that, like, if you were given something different?
This? Because that is 7 square root of 3. 7 square root of 3. Yep. Any other questions? Let's look at this one here. So again, we're going to be using a squared plus b squared equals c squared. We're using Pythagorean theorem to find the missing side length, and then trying to determine if it is a Pythagorean triple. So which one is the hypotenuse? 25. That means A and B are 15 and x. So we can plug those in for A and B, which gives us 15 squared plus x squared equals 25. So 15 squared is going to be 225. And 25 squared would give us 625. Now we would subtract 225 from both sides, yes. Which would tell us that x squared equals yes. And when we take the square root of both sides, x would equal 20. And that one's actually not that bad, because if we look at it this here, because we can say it's 4 times 100, what times itself is 4? 2. And what times itself is 100? And 2 times 10 is? Now would these three here be a Pythagorean triple? Yes. Any other questions on these here? How do we feel about finding the missing links using Pythagorean theorem and then determining if they are a Pythagorean triple? We feel good with this here? All right. If we feel good about this here, we'll look at this one, kind of a real world example of it, and then we'll move on to the next thing. The flagpole shown is supported by 2 wires. Use the Pythagorean theorem to approximate the length of each wire. Well, if we're looking at this here, this length, and this is x. Well, wait a minute. These 2 lengths are going to be the same. They're going to be the same. So, all I need to find is one of them. What is the hypotenuse for this here? So our 90 degrees is here, and the side opposite it is x. So C is going to be our x, and A and B are going to be 8.5 and well, nicely enough, 15.1 and 8.5 are on both sides, are both on the same side of the equation. Yes? So we could actually type into the calculator 15.1 squared plus 8.5 squared and hit enter. And what would that tell us? 300.26. And what would we do next? Square root both sides, so x is equal to 17.32. And it would technically be feet. And that's all we would need to do to solve for this here. Any questions on this? It was pretty much the exact same thing, just in a different form. We ready for the next part? The next thing we're going to look at is the converse of the Pythagorean theorem, because our Pythagorean theorem states in a right triangle, the square of the hypotenuse is equal to the square or the sum of the square of the lengths of the two legs. Or that if it's a right triangle, then a squared plus b squared is equal to c squared. Now, the converse is saying that if a squared plus b squared is equal to c squared, then it's a right triangle. So, looking at this here, if a squared plus b squared does equal c squared, then this is a right triangle. Now, looking at these three lengths here, which one's the hypotenuse? Because what is the square root of 113 as a decimal? .63 going on. So the square root of 113 is the hypotenuse. Any questions on this here? So we're going to use the Pythagorean theorem to see if this is a right triangle. Because if a squared plus b squared does equal c squared, then it is a right triangle. Now, as we just said, the square root of 113 is the hypotenuse. It is the biggest side, which means a and b are going to be 8 and 7. So we're wanting to see if these two are equal. Well, at this point here, we can square each one of these in or type it in, because we could type this entire side into the calculator, which gives us 113, because it would be 64 plus 49, which is 113. Now, on the other side, we need to take the square root of 113 squared. Well, a square root and square actually cancel, leaving us with, does 113 equal to 113? It's a right triangle, so yes, because a squared plus b squared did give us c squared. The sum of the square of the lengths of the legs gave us the square of the hypotenuse. Any other questions on this here? Does the Pythagorean theorem stated in a right triangle a squared plus b squared equals c squared? And the converse is saying, 312. Those here? So it is the biggest side? Oh. 3.12. I think it should be a little higher.
38.7.
Yeah. I think you had the fourth root of 95. So it is the biggest side. And most likely it is going to be the biggest side with the radical. Now, that means that c squared is going to be our 4 square root of 95 squared. And the values of a and b are going to be 15 and 36. Now again, this side here, 15 squared plus 36 squared, we can actually straight up type this in. We don't have to do this by hand or go one step at a time. And if we type this in, we get 1,521. Now we do need to take 4 square root of 95 squared. Now for this one here, I would make sure to put it in parentheses, because we're not applying the square to just the square root of 95, we're also applying it to the 4. And if we do this here, we get, because it's really going to be 95 times 16. What is it? 1,520. Yep. That would be 54. Well, 57, 0, 5, 9, 5, 2. So 1520. So are these the same? So is it a right triangle?
I was about to say, whenever I typed in the square root of 15.
It was not 4 squared to 95? And that's another way to go about it. Because if we find the hypotenuse or one of the side lengths using 36 and 15, and it's not the one given, it means it's not a right triangle. Let's look at this one here. This will be the last one we'll look at of this type. 4 square root of 5. It would not be 20. Because square root of 5 is going to be approximately 2 point something. So we're looking at something close to 9, I believe. So that tells us that the hypotenuse this time is 12, because 12 is the biggest side. So when we plug this in, we have 8 squared for A, 4 square root of 5 for B, and C is going to be 12 squared. Now we can type 8 squared plus 4 square root of 5 squared into the calculator. And again, when you type the 4 square root of 5 in, you'll need to put parentheses around the 4 and the square root of 5. Because there's a chance it won't apply it to both.
What is the parentheses?
It's telling it's one whole unit. We're squaring everything inside of it. Let me see. It didn't like the parentheses inside the radical. So we get 144. Now 12 squared is? Yes. It's a right triangle. Because a squared plus b squared did equal c squared. So last type of that. Any other questions on these here? Figuring out if it is a right triangle. If we feel good with those, the last thing we're going to talk about is the Pythagorean inequalities theorem. And the Pythagorean inequalities theorem has two setups. We have that a squared plus b squared is greater than c squared, and a squared plus b squared is less than c squared. So the two cases we have is either the hypotenuse's value is going to be bigger or smaller than the sum of the two legs, the square of the two legs. And if the hypotenuse is smaller, the triangle is actually acute. If the square of the hypotenuse is bigger, then it's going to be obtuse. And if they are equal, it is going to be right. So, verify the segments with lengths 4.3, 5.2, and 6.1 feet form a triangle. And then determine if the triangle is acute, right, or obtuse. Now, determining that the three lengths form a triangle, we did cover in a previous section. And the way that we do that is from the fact that the sum of any two sides is always greater than the third. So, really, for us to be able to determine if it's a triangle, we just need to take the smaller two lengths and make sure they add together to be greater than the third. Because if the third is a part of, because 6.1 is always going to be greater than the other two, so they will always add together to be bigger. Yes, sir?
So, wouldn't it be like a right triangle because 4.3 or 5.2 minus 4.3 is 9, and then like 5.2 plus 9 must not be equal.
We'll see. Now, 4.3 plus 5.2 is going to be bigger than 6.1 because 4.3 plus 5.2 is 9.5, which is bigger than 6.1, so this is going to be a triangle. So we can say yes for it being a triangle. Now, to determine if it's right, acute, or obtuse, we're going to use find out what a squared plus b squared is, and find out what c squared is and see how they relate to each other. You got to put a question mark in the middle. So the bigger length, the hypotenuse is always going to be c. And what is the biggest length? So we'll have 6.1 as c. A and B are going to be the other two lengths. So we would have 4.3 plus 5.2 squared. So we can first start off by finding either c or a squared plus b squared. Which one do y'all want to find first? So 4.3, so 45 point what? So 4.3 squared plus 5.2 squared is going to be 45.53. So 6.1 squared, as we typed it in, was 37.31. Which one is bigger? 45.53 is bigger than 37.31, yes? So this would be, because a squared plus b squared ended up being greater than c squared. So it's going to be acute. Any other questions on this here? All right. Let's look at the next one here. Well, verify that the segments form a triangle. Well, yes, because 3 plus 4 is 7. 7 is bigger than 6, so this would be a triangle. Now, to figure out whether it's acute, right, or obtuse, we're going to be going back to a squared plus b squared and c squared, and we need to figure out how do these two relate. Is a squared plus b squared going to be greater than c squared, or is it going to be less than c squared, or equal to c squared? Well, the values of a and b are 3 and 4. 3 squared plus 4 squared, and c is 6 squared. So the first thing we can do is 3 squared plus 4 squared. $25, because 9 plus 16, and 6 squared is And 36 is bigger than 25. So it's telling us that a squared plus b squared is less than c squared. Exactly, it is obtuse. So it's an obtuse triangle. Any other questions on this here? Now these sections do form a triangle because 2.1 plus 2.8 is going to be greater than 3.5. So it does make a triangle. Now we need to see how a squared plus b squared relates to c squared. Now the values of a and b for this here would be 2.1 and 2.8, and c is 3.5. So we can plug 2.1 squared plus 2.8 squared into the calculator and get 10.01. 25.
That's 3.5 times 3.5. That's 3.5 squared.
3.5 squared is, so what did you put in for 3.5? Squared plus 2.8 squared.
What?
Here.
Oh.
Yep. 12.25 and 3.5 is 12.25, yes? So these are equal, which means it is a right triangle. It is right. Any other questions on these here? If we feel good with this here, that's it.